Hi folks, we are looking here at the lesson 7 for unit 4, and we're going to talk more about multiplying and dividing powers. So we're going to be doing the same power rules as what we looked at earlier in unit 4, but we're going to be looking not just at variable bases, but also at situations where there's a number as the base, not just an x or a y, but we're going to be doing this with numbers as the bases. So we're going to start the same way we did for the previous lesson. Now, here we've got a bunch of expressions with bases and variables. So I know here that here I have 2 cubed times 2 squared. So I know that 2 cubed is 2 times 2 times 2. And that 2 squared is 2 times 2. So this is hopefully looking really familiar to what we did with the base of a in the last lesson on exponents. So we see that if we write these all out, 2 times 2 times 2 3 times, and 2 times 2 again, how many 2's are we multiplying together? That would be 2 to the exponent 5. So we're going to gather up those exponents, or gather up those factors of 2, and write it in a simplified form. And eventually we want to kind of be able to skip that middle step and figure out the pattern and go right to the answer. So if you guys can pause this video, try and fill in the rest of the chart in your notes and double check your work. Unpause when you're done and we'll double check. Okay, so hopefully you guys have completed this chart. Here I've got 3 to the exponent 4 times just 3. Remember that that counts as an exponent 1. And here I see I have 5 3's all multiplied together. Make sure you know how to use your exponent button. 3 to the exponent 5, double check on your calculator, is 243. The next one, we have 5 7's multiplied, 7 times 7 times 7, 5 times 3 7's multiplied together. So hopefully you've counted those up and said I have 5 7's times 3 7's, so all together I have 7 to the exponent 8. And that is going to be pretty big, but my calculator can do it. It's 5,764,801. Big number. And the last one, this is getting to the point where I'm thinking, oh my goodness, I think we see the pattern and I don't want to write all of these out over and over. But I will. 1, 2, 3, 4, 5, 6, 7 10's multiplied by 2 more. And we count that that would be 10 to the exponent 9. So hopefully you guys are seeing this pattern just like the last time. And 10 to the exponent 9 is going to be 1 billion. Super big. But I can kind of squeeze it in there. So again, we see that the pattern here is going to be when we're multiplying, we're going to add the exponents. When you're multiplying powers with the same base, notice I had to have 2 as a base and 2 as a base, or 7 as the base and 7. If they're different bases, you can't combine them together. And the important thing that people do tend to forget if it's not a variable base is to keep the base the same. We said that every single time. If you're multiplying, you keep the base the same and add the exponents. And with x's, I think people are more inclined to just keep it as an x. But with 7 or 3, people sometimes want to do some kind of operations and do funny things with those numbers, but you keep it the same. That's going to be the real key. So here we go. We're going to fill this in just like before. If we have the same base, we keep the base the same and add the exponents. So, whoops. If you're multiplying powers with like bases, again, they have to be the same. Keep that base equal and add the exponents. So here's an example down here of a multiple choice question that could have been from an EQAO in previous years. And this really highlights some of the common errors. So 5 to the exponent 3 times 5 to the exponent 4. Remember the rule here. We have to keep the base the same. So keep it as a 5 and add the exponents. So my correct answer is going to be C. 5 stays the same, add the exponents. That's what you're doing when we're doing these exponent rules. But you'll see some common mistakes in the other answers. So people who maybe picked A, it looks like they multiplied the exponents, doesn't it? And they were thinking, oh, I'm multiplying stuff, so they think multiply exponents, but we know we add them together. Then the other two answers kind of have the same options as the exponent, but they've multiplied those bases. And this is what tends to happen when the base isn't a variable like an X or a Y or an A or a B. People tend to think that there's some kind of math to do with those, but the rule stays the same. You keep the bases the same, so it stays as a 5. So we're going to do the same for the chart for the division. We're going to follow that pattern through again. So here I've got 2 cubed, so 2 times 2 times 2 divided by 2 squared. And if you write this out and then show you're reducing, we can simplify this to 2 to the exponent 1, which is just 2. So again, if you guys pause this video, stop it here and go through and fill in the rest of the chart, and then unpause when you're ready to continue to check your work. Okay, so I will fill in the rest of these. So 3 times 3 times 3 times 3 on top, and just 1 3 on the bottom. When I reduce, I would get 3 to the exponent 3, which is 27. Next one, I've got 5 7s on the top, divided by 3 7s multiplied on the bottom. I'm going to reduce those, 1 on top, 1 on the bottom each time, and I'm left with just 2 7s on top, or 7 squared, which is 49. And then the last one, 10 times 10, 7 times on top, 1 2 3 4 5 6 7, over 10 squared on the bottom. And reducing those in pairs, 1 on top, 1 on the bottom, leaves me with 10 to the exponent 5. So hopefully you guys see, it's 100,000. Hopefully you see that this follows the same pattern. What are we doing with our exponents each time? We're looking at those exponents and subtracting them. So we're taking the exponents, subtracting them, taking those exponents and subtracting them every time. So again, the rule is the same whether your base is a number or a variable. We keep the base the same and subtract the exponents. The bases, of course, have to be the same to start with. So make sure you get that filled in your notes. And then there's another multiple choice question. Again, this one highlights some of the really common errors that people make with dividing powers. So I see that I have 5 to the exponent 8 and 5 to the exponent 4. I keep repeating this, I know, but keep the base the same. That is a really common error. So I'm not going to have this one because that base is different. I'm not going to have that one. The base is different. Keep the base the same and subtract the exponents. So the base stays the same and you do 8 minus 4. So that tells me that B is the correct answer. Again, common errors here. I think they divided the exponents for the mistake they made in A, and I think they maybe divided out 5 divided by 5 to get 1 for C. So some common mistakes that people might make. So we're going to go through and Just swap colors here. Simplify here in a few different cases, and then we'll have some where we have to evaluate at the end. So the first example, we have 3 to the exponent 7 and 3 to the exponent 2 on top. I'm going to keep the base the same. That's the important part. Add up the exponents. So 7 plus 2 is 9. And then I have divided by 3 to the 6. Now I'm going to do my division. Again, keep the base the same, and I'll subtract those two exponents. So 9 minus 6, is 3. Now, if this is a reasonably small number in the answer, then you can actually evaluate that. Like if it's huge, if it's like an exponent 12 or something, don't go doing those. But 3 cubed, 3 times 3 times 3, that's pretty reasonable to do. And just evaluate that actually to 27. So the next one, I have a bit more going on here to simplify, and I am going to simplify on the top first. I see I have 6 to the exponent 5, 5 to the exponent 6, 6 to the exponent 3, and 5. Now, first of all, I want to really highlight the ones that have the same bases that I can combine together. So I have 2 things on the top with a base of 6. I'm going to keep that base the same and add the exponents to get 8. I have another 2 things on the top that have a base of 5. Remember that this one has an exponent of 1 if there's no exponent showing. So now I have 5 to the exponent 7 when I add those up. Then 5 to the exponent 6 and 6 to the exponent 7. Again, I want to kind of color code this so I don't get mixed up, especially because sometimes they end up like lined up right above each other, but in this case they're not. This 6 to the exponent 8 is the same base as 6 to the exponent 7. So you really don't want to just assume that it's the ones right on top of each other, because it may not be. So here, when I have the same base, I keep the base the same and subtract exponents. So 8 minus 7 is 1. And then I have also same bases there. 5 to the exponent 7 divided by 5 to the exponent 6. Keep the base the same, subtract those exponents. Now we can evaluate. 6 to the exponent 1, that's just 6. 5 to the exponent 1, just 5. So then I have 6 times 5, which gives me 30. So again, reasonable small size numbers, you will just evaluate those to a final answer at the end. Okay, the next one, if you guys can pause this and give it a try, this is combining together number bases and variable bases. See if you can simplify this one. Okay, unpausing when you're ready. I'm going to look at the answer here. So I have to keep the things with the same base together. I can't combine things if the bases aren't equal. So I'm going to combine together the things with a base of 2. 2 to the exponent 4, 2 to the exponent 3, keep the base the same and add up those exponents. Then I see 2 terms with a base of m. So I'm going to keep the base the same and add the exponents. So 5 plus 8 is 13. Then we have 2 to the exponent 7, which feels like a really big exponent, but it's not that big of a number. It's actually just 128. I can't do anything with m to the exponent 13 because that's a variable base. But for the number base, the 2 to the 7, I can evaluate that and see what the answer is. Okay, now this is one that we would have done in the last section on power rules, because these numbers are not powers. They're just regular number coefficients. They don't have any exponent. They don't have anything that we have to do in terms of the power rules. This goes back to what we did before. We're going to multiply the coefficients and we're adding the numbers, adding the exponents on the like bases. So the number parts are coefficients 3 and 5. They're not powers, they're not exponent rules, they're just regular numbers, and we just do 3 times 5 is 15. Then we look for the next type of bases. So I have x squared and x cubed. Those have the same base, so I'll keep the base the same and add up the exponents. 2 plus 3 is the exponent 5 for my x's. Then I look at the next base. I have some y's. I have y to the exponent 4 and y squared. So I'm going to keep the base the same and add up the exponents. 4 plus 2 gives me 6. And very similar for division. If you want to pause this and give it a try yourselves, and then unpause when you're ready to check your answer. Okay, so again, we're going to divide the coefficients and subtract the exponents where we have like bases. My coefficients are just regular numbers. 24 divided by 8 is 3. I have like bases here with x to the exponent 6 and x squared. When I subtract those exponents, I get x to the exponent 4. I also have like bases with y's. I'm going to subtract those exponents. 15 minus 5 is 10. So that's my final answer. I don't have anything else I can do to simplify there. And the last example for this one. This is a bigger, kind of more complicated one, and then it also wants us to simplify, then evaluate. So it tells us actual numbers to put in, but we're not going to sub in that x equals 3, y equals -2 right now because we've got so many x's and y's and it's such a mess. If we simplify it as much as we can, it'll be much easier to substitute. So we're going to multiply on top just like we did in the previous questions. Then we'll divide top to bottom. So when I'm multiplying here, multiply the coefficients. So 4 times 5 is 20. And then I'm looking for the bases that are the same. I have x to the exponent 4, x to the exponent 3. So that gives me x to the exponent 7, adding up those exponents. Y cubed and y to the exponent 5. Base stays the same, add up the exponents, and it's 8. I'm not doing anything yet with the bottoms, so I'll just rewrite that. Now I can divide. I'm going to divide 20 divided by 10. The coefficients are just regular numbers. Then I'm going to divide here, x to the exponent 7 divided by x to the exponent 5. Keep the base the same, subtract the exponents. 7 minus 5 is 2. And then with the y's, I'm going to keep the base the same. 8 minus 5 is 3. So now we've simplified it as much as we can. We're going to substitute in our numbers. So x is 3, so that's 3 squared, and y is -2. So remember, you're going to take your number and put it in right where that variable is, and you always use brackets when you substitute it in. Otherwise, it might look like adding or subtracting, and we know that it's all multiplication there. So now we just evaluate this with BEDMAS. We're going to do exponents, so 3 squared is 9. Now -2 cubed. Negatives sometimes throw people off. That would be -2 times -2 times -2. So a negative times a negative is positive, but then times another negative, that'll be negative. 2 times 2 times 2 gives me 8. So this is kind of my thought process on this one. You can also use a calculator if that feels easier for you. or more comfortable. Then I would just multiply right across. 2 times 9 times -8. And you can, of course, use your calculator for that. It's a little bit big. It's -144. So now you guys are all set to do the lesson 7 homework. Remembering, always look for your same bases and follow those exponent rules. When you're multiplying, you add. When you're dividing, you subtract exponents, always keeping the base the same.